Hi, good day. I am Dr. P. Senthil Kumar, Associate Professor, Department of Mechanical Engineering, University of Engineering Technology, Coimbatore. Today we will learn about the turbine, that is Pelton turbine, in the fluid mechanics chemistry lab. Okay. So in the panel board, you can see here the three different pressure gauges: the pressure of throat, the pressure of the turbine, and the pressure of the throat, and then the pressure of the inlet. You can see three pressure gauges. You can see. So tachometer, the speed of the turbine. This is on-off switch. Okay. This is a Pelton wheel turbine. The objective of this experiment is to measure the performance of this turbine. Okay, how the output of the turbine is converted into electrical power. Okay, but actually here we are not having electrical power here. So what we do to measure the output of the turbine, we have the row brake dynamometer. So by using this system, we can measure the output of the turbine. Okay. So first we have to switch on the turbine. Once you switch on the turbine, then we have to adjust this valve. So here actually normally the turbine means water has to come from outside, from the dam it has to come. But here we don't have any dam. So what we do, we use a pump. From the pump we are sending the water under force. This is the Pelton wheel turbine. Okay, this is a Pelton wheel turbine. So this turbine, when the water is coming and impinging on the vanes or buckets, it start rotating. So how much speed it is rotating, we can measure using the tachometer. By using the row brake dynamometer, we can measure the output of the turbine. Okay, first, once you switch on the turbine, we have to adjust this valve. Okay, in such a way that you have to open this valve. Okay, so it's close to position. If this means close to position, we have to open this valve a little bit, and we have to adjust in such a way that this tachometer reading should show 1500 rpm. It should show 1500 rpm. Once we reach the 1500 rpm, then we have to adjust this valve. We have to open these valves. Okay, this valve, the pressure gauge valves, this valve we have to open a little bit. This also we have to open a little bit. Then also in the turbine gate we are having another valve, that also we have to open it. Okay, just 2 turns, this is enough. That's all. Once we started this, then we have to do what we have to do. First we have to note down the pressure of the three gauges. Okay, one is the turbine pressure, another is the throat pressure, another is the inlet pressure. These three pressure we have to note down first. Okay, this initial reading. Then at the time the speed will be 1500 rpm, revolutions per minute. Then what we have to do? We have to take the weight from here. Okay, the weight is available here. So here in the row brake dynamometer, we are having two loading systems. One is the spring balance, another one is the dead weight. Okay, first we have to put the dead weight. Okay, 2 kg. Because a little bit deflux is there. So each reading shows 50 grams. So that how much its weight is coming here, spring balance weight, that we have noted down. See, first see now here, inside is 0. So approximately you are converted, you said it is 0. Okay. Or from where it is starting, that value you will take it as 0. Once you loaded it, you will get deflection. Okay. You can see how much is deflection. So this is the value you note down. Okay. So then we have note down the throat gauge, pressure gauge, throat gauge. Okay. We note down the pressure gauge here, throat turbine head, throat inlet pressure. Then we have note down the RPM also. Once we load it, RPM will change, reduce. That also we note down. Then we have to add another weight also. Okay. We have the 4 kg weight. We have to add the 4 kg weight while running. Okay. So these are two processes weight. Balance on configuration. Okay, this is a very simple experiment. So Pelton we are having the pumping system. From the pumping, we just open the valve and then we see the RPM speed is around 1500. Then we note down this, there is no reading here, dead weight is no weight. So there may be some reading may be there, just note on this. Then we have to put the load here and we have to find how much speed is reducing, how much gas are changing the pressure. Okay, that's all. I am switching on the turbine. Okay, but I cannot explain. Even if I explain, you cannot hear. When I am switching on the turbine, just see how it's operating. You see now turbine is speed is increasing. Now the speed is increasing. We are set at 1500. You can see how the turbine water is coming. You can see how the turbine is rotating and it is giving the output. Now you can see the pressure. Turbine, port, inlet. Now I have to put the dead weight. Little bit deflection is there, little bit deflection is changing. Now we put the dead weight of 2 kg. Now you see the RPM is reducing. You see from above 1500 RPM, now it has reduced to 1400, still it's reducing. You can see the change in pressure of the turbine as well as the other heads. Now we are going to put the 4 kg. Now we put the 4 kg weight. You see the RPM has reduced to 1000. Still it's reducing, RPM is reducing. That's all, balance all calculations. Thank you very much.